Hello students. In the last session we had talked about integration, use of integration in motion in straight line, right? And we had done few questions based on integration. Okay, so let us quickly understand now how many different basic formulas we require in entire physics from integration, right? So few algebraic function, trigonometric function, logarithmic function are used. Okay, so we will do it today, and after today's session we will move further. So this is the end of the mathematical tool, especially that calculus based. We had done differentiation, we had done integration. So remaining portion of the integration we will be doing today. So let us quickly move further. Let us quickly move further. Integration. We had understood the basic idea behind integration. Now I am giving you, few questions based on integration. Whatever you have understood. So let us practice some integration questions, right? First we have understood x square into dx. Just simple. And in today's session would be a little faster, right? We'll be solving problems faster, because I believe that you have understood the basic idea. From the basic idea we will move further to the advanced level, right? So x square dx. So what is the answer? Just tell me. You know the formula. Let us quickly recall the formula. X raised to power n into dx equals x raised to power n plus 1 divided by n plus 1. Plus there is constant, right? We will talk about this, why this constant is appearing and why it is required. Okay, so that is also the thing which we need to understand. This is a definite integration or indefinite? This is indefinite. We don't know the values, right? We don't know the values. What value this x will assume, we don't know. So that's why it is indefinite integral, right? This is a basic formula. Now, what is going to be the answer? X cube by 3 plus some constant. For the sake of just understanding what concept constant we will understand, we will find out what constant will be there and why that is important. Okay, let us quickly understand. As you know that integration and differentiation are the reverse process, right? Like integration is a reverse process of differentiation. We have understood for some time we have done it. V equals dv, v equals dx by dt. Try to understand this. If we have to find out dx, we have to find out displacement. What we did, v into dt we had done this integration. So this came out to be x, and this is something. Suppose we have got v equals 2t cube plus 5. Mind it, this is important. Okay, this is important. So dv is this. So suppose dv is this. We have put it here, 2t cube plus 5, 2t cube plus 5 into dt. So if you will work it out, you will get it 2 into t raised to power 4 by 4 plus 5t. This is what you are getting. As per our basic idea, basic concept, 2t raised to power 4 divided by 4 plus 5t. We have understood this. Now x came out to be this. Okay. Now if you substitute, if you have this 5t, that we have understood, right? If there would be some constant also, suppose we have got x equals we have got x equals, let's say, t4 by 2 plus 5t plus 3. We have got x equals this. 3 here is constant. Okay. If we find out v, what we will get? Dx by, just hang on. In a couple of minutes, you will understand why there is a need of putting this constant that can actually make up these constants, right? Because we don't know what constant would be there. I will explain you why this is important. So let us quickly understand. If you have got x equals this, velocity will be coming out to be dx by dt, that you will work out d by dx and dt, then whatever t square by 2 plus 5t plus 3. If you will work it out, what you will get? You will get t raised to power 3. T raised to power 3. 2 t raised to power 3 plus 5. Okay? Mind it, this is going to be there. T 1 by 2, 2 into 1 by 2, because this is constant, t raised to power 2 minus 1, this is 1 actually. This is 1. Okay? So, this is what we are getting. Oh, wait. This is 4 actually. This is 4. My mistake. I have taken x equals t raised to power 4. So, t raised to power 4 by 2 plus 5t. This is our expression of displacement. Okay. Velocity, if we will work out, what you will get? Velocity we will have equal to what? 1 by 2 into 4 into t raised to power 3. Right? Plus 5t will come out to be 5 into 1 into t raised to power 1 minus 1, that is 0. Something raised to power 0 is 1. So 5, only 5. T raised to power 0 equals 1. So this. Now for this 3, because 3 is constant, rate of change of 3 is 0. So this is going to be 0. So what is our final answer? 2t cube plus 5. This is v. So what did you observe? Here we got x equals 2t by 4, 2t raised to power 4. The final value that here we got is x equals t raised to power 4 by 2 plus 5t. Just keep this thing in mind. Just keep this thing in mind. We have got x equals t raised to power 4 by 2 plus 5t. Velocity for this also is 2q plus 5. And here if we take x equals t raised to power 2, here we know the function, we know the displacement, we found the velocity. Here we had the velocity, we found the value of displacement, x, doing integration. Now what we are actually trying to do is, we are trying to find out the value of this constant c and why that is appearing. Why that is appearing? Why is that significant? Comparisons we need to do. What comparisons? If you take x equals this, if you take x equals this value, if you take x equals t raised to power 4 by 2 plus 5t plus some constant 3, then you will get this value velocity 2t cube plus 5. Since differentiation and integration is reverse process, as I have told you, with the help of integration we can determine the value of x. So that value of x must come equal to this if we have got the same velocity. The velocity, here we knew the velocity, we found the displacement, right? So this displacement value must be equal to this. Since velocity we have taken in the two cases same, 2t cube plus 5, here also 2t cube plus 5. But there is a difference. There is a difference. If you see displacement coming out to be t raised to power 4 by 2 plus 5t, there is no constant here. There is no constant here, as you can see. So this constant 3 must be there. If it has to be the constant, if it has to be the correct value of displacement, if it has to be the correct value of displacement when velocity is this, then there must be some constant in the expression. To incorporate that constant, we don't know what constant might be there. So we put this c here. Okay? We put this c here, some constant, we don't know the value. That unknown constant might appear in the expression of this displacement that has got same velocity expression, right? Velocity, you can see, has got same value. So displacement must have the same expression, but that was not there. To incorporate that unknown constant value, we put this c here. So that is the basic idea. I hope you have understood this. So keep that thing in mind. In general, this is the formula, right? In the beginning, I have not told you, just to let you know it later. Now you have understood why this constant must appear. Okay. Now when there is some definite integral values, whatever values you will substitute, this will also come up. So that way we will move ahead. So this was the basic idea behind. Okay, so as we had to do further, what? Quick practice of the integration. So the basic ones, this is x raised to power, let's say now x raised to power half. This is half, you can see. Okay, what is the value? Can you do it? Can you solve it? Yes, it is easy. How? We will take that x raised to power half into dx. You are aware of this. Square root of x means this. How will you get it? So x raised to power half plus 1 divided by half plus 1 plus some constant. What you will get? X raised to power 3 by 2 divided by 3 by 2 plus some constant. That means 2 by 3 x raised to power 3 by 2 plus some constant. Okay? This is what we are going to get. Right? So this is the value of square root of x, right? Now, let us do another question. Let us do another question. Let us do another question. 1 by x raised to power, 1 by x raised to power half. Right? This dx. What you will get? X raised to power minus half, right? Into dx. Just do it. Problem number 2. Just do it. What you will get? Practice with me. I'm sure you will understand this. And you have understood the basic idea. Now little practice is required. And there are multiple things we have to be careful about. Few formulas based on trigonometric function, exponential function, logarithmic function we are going to do. Okay, so this, what you will get? X raised to power minus half plus 1 divided by minus half plus 1 plus c. So what is the final answer? X raised to power what? 1 minus half is half. Okay, this is half. Now what is this? Half again in the denominator also. So what you will get? 2x raised to power half, right, plus c. That means 2 square root of x plus some constant. Okay, this is what we need to do. So there are many other questions. Now quickly understand, if you have to do this plus 1 by square root of this x dx. This we can do. This is the practice question, just do it. Individually we will do actually, right? So square root of x dx plus 1 by square root of x dx and this value. So this you can do. Further, if we have to do now trigonometric function, integral of some trigonometric function. Integral of trigonometric function. Trigonometric function. So first is sine x dx. Mind it, this is very simple. You know that differentiation of sine x is cos x. Okay, differentiation of cos x is minus sine x. Differentiation of cos x is minus sine x. So this gets reversed. Okay, this gets reversed, opposite. So for sine x dx you will have, minus cos x, right? Okay. Now for cos x dx, integral of this will be what? Plus sine x. Okay. Now here we need to do other things. Suppose we have sine of some constant I am taking. Let's say omega into x dx. What you will get? Here, be careful. For sine, it is minus cos x. So whatever angle is there, you just consider this angle. So minus cos of this angle, omega x, okay, let it be. This divided by. Now look at the value of here, coefficient of x, coefficient of this variable. What is this? Omega. So that coefficient of x you have to divide here. Okay, so what we will get? We will finally get in this manner. We will get this minus cos omega x divided by omega. Minus cos omega x divided by omega. So this is something that you need to keep in mind. If you have got trigonometric function, angle has got some constant into that variable. It is in this manner. So constant into some variable. So what you will do, you will put that, for the entire angle, whatever, and then divide it by the coefficient of this angle, coefficient of that variable. X here is the variable. So let us quickly do one more. If you have got sine omega t dt, integration of this, what do we get? Integration of this will be minus cos omega t divided by omega. Minus cos omega t divided by omega. Is that okay? As we have understood, sine of angle becomes minus cos of angle. Now here angle has got omega into t. Variable is t, but this is constant. Some constant value. So that you will divide. You will put it in the denominator. Okay. Similarly, cos omega t dt will be what? Sin omega t by omega. Sin omega t by omega. Right? Okay. Now we have the products, right? We have some other values, right? Let's talk about this sin omega t into cos omega t. If this is going to be there, I want you to understand this. Into dt. There are ways to do this. There are multiple ways to do this. But the simplest one I'm going to take up is this. You know, sine twice of that angle, here omega t is the angle, this equals 2 sine omega t into cos omega t. 2 sine omega t into cos omega t. That means sine omega t into cos omega t equals sine 2 omega t by 2. So this is what you will get. I am substituting this sine 2 omega t 1 by 2. In place of this, I have written this. Right? Now, this becomes easier to do. Let us take out the constant value from this integral symbol. Okay, I have taken it. Now, the sine of this angle, mind it, sine of this angle. So, this will be minus cos 2 omega t divided by, what is the coefficient? Coefficient here is 2 omega, right? Coefficient of t is 2 omega. So, we have already done for the entire angle, this divided by the coefficient, that is 2 omega. 2 omega, right? So this is our result. The final result for this equals minus 1 by 4 omega into cos 2 omega t. Right? This is what we are going to get. So quickly we have to recall this very simple thing. If you have got like, suppose I have sine 5x into dx. What I will do? Tell me quickly. Sine becomes minus cos of this angle divided by coefficient of this, that is 5. Okay? That's it. So these are the simple things. Simple technique. Now, let us move further. Let us move further. You have to have this exponential thing. There is some value like this, exponential function, e raised to power x into dx, exponential function. We call it exponential function. Actually what? You have some functions. You will come across functions. I have talked about that. Functions are basically two variables are depending upon one another in a given mathematical expression, like the way they are depending upon one another, two variables, the way they are depending upon one another has got mathematical expression. So mathematical expression which relates the two variables is a function that you can understand. So different functions, right? Suppose I am saying y is depending upon x square. So this is algebraic function, right? Similarly, we have done trigonometric function. Now this is exponential function. So in this case, what this is going to be, simply you will have this value plus constant. Okay, one more thing. You must ask me, what is this value of E? Value of E is, very close to 2.7. 2.7, right? And you will have this, have the use of this E while doing logarithmic function, right? Natural log, common log. There in natural log you have got this base as exponent, right? This is called exponential function. Now, as per the basic stuff, what we have till now understood, if you have got e raised to power 5x, I'm not saying that only this will be 5 always, any constant, okay, consider any constant. So let's say omega into t, e raised to power omega into t into dt, right? So variable here is t, omega is constant. So in this scenario, what will happen? you will have this e raised to power omega t, okay, as it is. This divided by, what is the coefficient of t? Omega. Just substitute this. This is how we go about it. Okay, so these are the important functions where integration, integrals we found. There are few more integral values. We will talk about this later on, right? In the next session, we will wind up and we will do more questions based on other forms of integrals, right? So till then, whatever we did, practice and enjoy learning and mastering physics. All the best.